The grandfather paradox. If a person were to travel back in time and successfully prevent their biological grandfather from meeting their grandmother, this single action would theoretically prevent the conception of the time traveler's parent. Consequently, it becomes entirely impossible for the time traveler to have ever been born. Because the time traveler was never born, they could never have built a time machine, and they could never have traveled back in time to interfere with their grandparents. This means the grandparents do meet, the traveler is born, and the cycle of logical impossibility repeats infinitely. The paradox forces theoretical physicists to confront the fragility of causality, the strict rule that an effect cannot precede its cause. To resolve this, scientists propose two main theories. The first is the Novikov self-consistency principle, which dictates that the universe will physically prevent any action that creates a paradox. If a time traveler tries to pull the trigger to kill their grandfather, the gun will theoretically jam every single time, as the timeline is rigid and deterministic. The second resolution is the multiverse theory. In this mathematical framework, the exact moment someone arrives in the past, a completely new, branching timeline is created. The traveler can prevent their grandfather from meeting their grandmother in this new universe, but it does not erase the original timeline. The traveler is simply trapped in a parallel reality where they technically never existed, leaving the original universe perfectly intact. The predestination paradox. If a time traveler attempts to go back in time to alter a specific tragic event, their very actions in the past become the exact direct cause of the event they are trying to prevent. Unlike the grandfather paradox, where the timeline breaks, this creates a perfectly stable causal loop. It implies a strictly deterministic universe where time is not a flowing river that can be diverted, but rather a solid block of spacetime where the past, present, and future are already written, and completely unchangeable. Imagine a man whose wife dies in a hit-and-run car accident. Overcome with grief, he spends decades building a time machine. He travels back to the exact night of the accident, frantically stealing a car and speeding down the dark road to push her out of the way. In his desperate rush, he loses control of the vehicle, strikes a woman in the dark, and drives away in a panic, only to realize he was the driver who killed his own wife. His attempt to change history is the exact mechanism that fulfilled it. This paradox completely removes the concept of human free will. It proves that any knowledge of the future and any subsequent attempt to avoid it is already permanently factored into the timeline. Fate cannot be escaped because the struggle to escape it is the very action that seals it. The twin paradox. If one identical twin remains on Earth while the other makes a journey into deep space in a high-speed rocket traveling at near the speed of light, the traveling twin will return home to discover that the twin who remained on Earth has aged considerably more than they have. This phenomenon is caused by time dilation, a fundamental rule of special relativity which dictates that time moves slower the closer a physical object gets to the speed of light. The paradox arises because in relativity, all motion is strictly relative. From the perspective of the traveling twin, they were stationary inside their ship, while the Earth and the other twin sped away from them at the speed of light. Therefore, the traveling twin assumes the earthbound twin should be the one who aged slower. The symmetry between the two twins is broken because the traveling twin experienced acceleration and deceleration in order to turn the spaceship around and come back. This change in inertial frames definitively proves who was moving and who was stationary, resolving the apparent contradiction. If a human were to travel near the speed of light for just 5 years, they would return to an Earth that had aged 50 years, permanently separating them from their own generation. Schrödinger's cat. If a cat is placed into a completely sealed steel box alongside a tiny amount of a radioactive substance, a Geiger counter, a hammer, and a glass vial of deadly hydrocyanic acid, a quantum superposition is created. If the radioactive atom decays, the Geiger counter detects it, drops the hammer, shatters the glass, and kills the cat. If the atom does not decay, the cat lives. According to the Copenhagen interpretation of quantum mechanics, a subatomic particle exists in all possible states simultaneously until it is directly observed and measured. Therefore, until the heavy steel box is opened and a human being makes a conscious observation, the radioactive atom is theoretically simultaneously decayed and not decayed. By direct extension, this means the vial of acid is both shattered and intact, and the cat is quite literally both alive and dead at the exact same time. This creates a profound paradox. If unobserved matter can exist in multiple states at once, at what exact point does reality choose a definitive outcome? Does the Geiger counter count as an observer when it detects the decay? Does the cat count? Or does the quantum wave function only collapse when a conscious human opens the box? This measurement problem forces us to question the very nature of objective reality, suggesting that the universe remains in a blurry state of infinite probabilities, until the act of observation forces it to collapse into a single, physical truth. The delayed choice quantum eraser. If you fire a single particle of light through a barrier with two open doors, it appears to pass through both doors simultaneously as a wave, creating a wavy pattern on the back wall. However, if you place a camera directly at the doors to measure which path the particle chooses, the light appears to change its behavior, passing through only one door as a solid dot. To see the paradox, we must trace 3 distinct points in time. At point A, in the past, the particle passes through the doors with the camera turned off, traveling as a wave. At point B, in the present, while the particle is still flying in mid-air, a switch is randomly flipped to turn the camera on. At point C, in the future, the particle hits the back wall as a solid dot. Here is where the timeline defies common intuition. For the particle to hit the wall as a solid dot at point C, it must have passed through only one door at point A. Yet, at point A, the camera was completely off. It almost looks as though flipping the switch in the present forces the particle to travel backward in time to point A, rewriting its own history to match our measurement. Does the past actually exist, or is it simply waiting for us to create it? The Fermi Paradox. If the universe is 13.8 billion years old, containing billions of stars and planets, some calculations suggest intelligent life should mathematically be everywhere. Even if life is incredibly rare, the sheer scale of the cosmos guarantees that millions of advanced alien civilizations should have evolved by now. Many of these civilizations would be millions of years older than humans, possessing the technology to easily travel across galaxies. Yet when we point our radio towers at the stars, we receive only flat, dead lines. The night sky remains completely silent. One proposed explanation is a concept called the Great Filter. Imagine this filter as a giant physical brick wall that every developing species must eventually crash into. If this wall is already behind us, it seems as though humanity is a mathematical anomaly, having successfully survived a barrier that destroys everyone else. But if the brick wall is still in front of us, it may mean every advanced civilization eventually reaches a point of high technological power where they inevitably destroy themselves. Some interpretations suggest that the silent stars are simply a massive cosmic graveyard. Which side of the wall are we actually on? The black hole information paradox. According to a fundamental law of physics, information about the state of any object can never be permanently destroyed. If a wooden block is burned, the information is not gone. It simply transforms into ash, smoke, and heat. With a perfect computer, you could theoretically track every single ash particle and rebuild the original block. However, if you throw that same wooden block into a black hole, the gravity is so intense that nothing, not even light, can escape. The block is pulled past the event horizon and crushed into a single point. This becomes a massive crisis because black holes slowly leak random heat energy over billions of years, a process called Hawking radiation. Eventually, through this leaking radiation, the black hole will completely evaporate and vanish from the universe entirely. The problem is that this leaking radiation is completely random and contains absolutely no clues or data about the block that fell inside. If a black hole consumes an object and then completely evaporates into random heat, the physical information of that object has been permanently erased from the universe, violating a core law of quantum science. To resolve this contradiction, scientists propose the holographic principle. This theory suggests that as the block falls in, its detailed information is not actually lost inside, but is instead flattened and printed like a two-dimensional sticker on the outer surface of the black hole, surviving long after the physical object is destroyed. The Bootstrap Paradox. If an object, a person, or a piece of information is sent back in time, this past event can theoretically cause its own original creation in the present. As a result, the object exists within a closed, infinite loop without ever having been originally created by anyone or anything. For example, if a time traveler goes back to the Elizabethan era to meet William Shakespeare, but discovers that Shakespeare has never written a single word, the traveler might hand Shakespeare a complete anthology of his own plays to ensure history plays out correctly. Shakespeare then publishes the plays under his own name. Centuries later, the time traveler buys that exact same printed book and brings it back in time. The paradox asks a terrifying question: who actually wrote the plays? The information simply exists without any point of origin. This paradox deeply violates the second law of thermodynamics, which states that entropy, or the degradation of matter, must always increase in a closed physical system. If a physical object like a pocket watch is passed through this time loop infinitely, it should eventually age, rust, and turn to dust. Yet in this scenario, the object is perfectly trapped in time, defying both the linear progression of human logic and the physical degradation of the universe. Polchinski's paradox. If a billiard ball is thrown into a temporal wormhole at a very specific angle and speed, the wormhole transports the ball a few seconds into the past, ejecting it out of the other end. However, if the exit is positioned in such a way that the older billiard ball strikes its younger self right before the younger ball can enter the original wormhole, this collision alters the younger ball's trajectory. It is knocked completely off course so that it never enters the time machine in the first place. It is the exact mechanical equivalent of the grandfather paradox, but stripped entirely of human free will, emotion, and choice. It relies purely on the cold, hard laws of kinetic energy and general relativity. This thought experiment was originally designed to prove that time travel violates the core mechanics of the universe. However, theoretical physicists later calculated a mathematical solution known as a weak consistency blow. They proved that the ball could emerge from the wormhole and strike its younger self with just a slight glancing blow. This minor collision would slightly alter the younger ball's path, but not enough to miss the wormhole entirely. It would enter the wormhole at a slightly different angle, which would then cause it to emerge and deliver that exact same glancing blow, creating a perfectly consistent, self-correcting loop of physical reality. Wigner's friend paradox. If a human scientist is placed inside a sealed laboratory to conduct a quantum experiment, such as measuring whether a single light bulb is turned on or off, and a second observer stands completely outside the closed laboratory door, a contradiction in quantum states emerges. The scientist inside performs the measurement and observes a definitive result. The light bulb is either on or off. At this exact moment, from the internal observer's perspective, the quantum superposition has collapsed into a single physical reality. reality. However, from the perspective of the observer standing outside the sealed door who has no knowledge of what happened inside, the entire laboratory, including the light bulb, the switch, and the scientist, is still mathematically existing in a state of quantum superposition. To the outside observer, the scientist inside is simultaneously observing an illuminated bulb and a dark bulb. The paradox asks at what exact moment the wave function actually collapses. Does reality crystallize when the internal scientist looks at the bulb, or does it wait until the external observer opens the door and asks what happened? If we trace this logically, both observers are technically correct within their own isolated frames of reference. This suggests that there is no single objective master reality. Instead, reality is completely split, meaning two different observers can experience entirely contradictory yet mathematically valid versions of the same universe.